In this video, I want to show that the weakest precondition implies the invariant holds, so that we can start proving this program segment correct. So, the first thing I need to do is instantiate. And the invariant was that x is equal to x hat and y is equal to y hat, and both of the inputs are positive. The invariant is that the GCD of x, y is the GCD of x hat, y hat, and x is between 0 and x hat, including possibly x hat, and y between 0 and y hat, possibly including y hat. So we need to show that this predicate is true, equivalent to true. How do we do this? Well, here's a strategy we often use. Notice that we know that x is equal to x hat and y is equal to y hat on the stronger side for our precondition. What I'm going to do is use something called substitution, which allows me throughout the predicate to substitute where I see x and x hat, or where I see an x hat and x, it doesn't matter which. I'm going to keep it here, but I can then substitute elsewhere so I can get back and forth. So by substitution, I'm going to leave the stronger side as is, so I'm going to go back and write it as Q. Notice usually when I'm proving things, I don't instantiate Q until later, but this time I did right away because I noticed I could then use substitution. But now I'm just going to again write it as Q for a while. Q implies, now if I substitute for x and x hat, that gives us the GCD of x hat, y hat, by substitution again, is the GCD of x hat, y hat. And what I'm going to do is substitute here x hat for x and y hat for y also, but I'm also going to split this interval because I can read this as 0 is less than x and x is less than or equal to x hat. With substitution, I could write this as 0 is less than x hat and x hat is less than or equal to x hat. And then we would have 0 is less than y hat and y hat is less than or equal to y hat. Now I can do some simplification because I know by identity this is true, that the GCD of x hat, y hat is the same as the GCD of x hat, y hat. I also know that x hat is less than or equal to x hat by identity, or you might think of it as algebra or arithmetic. It doesn't matter what you call it. The idea is x hat is equal to x hat, so it's less than or equal to x hat. So I'm going to say by identity, this expression is equivalent to Q implies true and 0 is less than x hat and true and 0 is less than y hat and true. Okay. If I now want to simplify further, by and simplification, any expression and true is the expression. So this is just Q implies true and the expression that 0 is less than x hat and 0 is less than y hat. But I can rearrange, and so by the commutative property, by associative property, and by many and simplifications, actually 3 and simplifications, this is equivalent to Q implies that 0 is less than x hat and 0 is less than y hat. Well, let's look at Q. What is it? Again, by instantiating, just to make sure that I have things in an order where I can see what's going on, this is equivalent to x is equal to x hat and y is equal to y hat, and x hat is greater than 0 and y hat is greater than 0 implies that 0 is less than x hat and 0 is less than y hat. Okay. 0 less than x hat is the same as x hat is greater than 0 by algebra, arithmetic, or whatever you want to call it. So this is equivalent to this. This sub-expression is equivalent to this sub-expression because y hat is greater than 0 is equivalent to 0 being less than y hat. And so our two sub-expressions have some commonality. Commonality being they both have x hat greater than 0 and y hat greater than 0 involved. But the precondition has an extra. But notice I can use weakening and strengthening, because if I think of this part that they have in common as being the predicate P, and the part that the precondition has that the invariant didn't, through simplification, have, it turns out that we have things in the form of P and Q implies P. So by the commutative property, if I want to reorder, and by weakening strengthening, I'm done. This is equivalent to true. So S for success, I guess. We're finished with the first step in proving that program segment correct.